All right, so like I said, if you just watched part one of the linear combination of vectors lesson, this is going to be our second example. So just rereading the question, show that the vectors u and v, and we've been given the value of each vectors, are coplanar. That's the first part of our question. And then after that, write x as a linear combination of u and v if the value of x, and we're given that it's 5 comma 8. Okay, so in order to do this, what we have to do, if they're coplanar, I'm actually going to assume the exact opposite. So I'm going to assume that u and v are collinear instead of coplanar. Because then if I can prove that they're collinear, then I obviously know that they're not coplanar, or vice versa. If this proof fails, then I've proven that they are coplanar. So that's what I'm going to do. I'm going to do the exact same thing I did for question 1 and just let u be equal to v multiplied by some m value. And now I'm just going to calculate everything. So I've got -1 and 3. So I'm writing my two vectors in coordinate form. I mean, you don't necessarily have to do that, but I personally just prefer it because I think it's cleaner, right? I don't want to get my I, j, and k component variables mixed up with my m variable, which if I'm extra careful, that's not going to happen anyway, but why take the risk, right? So now I set this up and I get my two equations. So then I would have -1 would be equal to 2m, and then I would have 3 is equal to 4m. And now I calculate each one individually, divide both sides by 2, so I'll just end up with m is equal to -1 over 2. And now let's see if this gives me the same value. I divide both sides by 4. There's not even a negative, so I obviously know it's not going to work, but I'm just going to write it anyway. M is equal to 3 over 4. So no scalar multiple m exists to make my assumption true. So this part is not mandatory to write. I'm just kind of writing down my logic so that you can have it in your notes. But now, therefore, this part we do have to write the assumption is false. And because my assumption is false and they're not collinear, then therefore I've proven that u and v are coplanar. All right. So, good news, we're done, but we're only done half the question, right? Because we've only done the first sentence. Now I have to write x as a linear combination of u and v if the value of x is 5 comma 8. So that's what we're going to do. Let me just separate this, the two parts of the question. So now I'm going to write x as a times u plus b times v. So kind of similar to what we did before, but we're using the second property off our page because now we have a value of a and b, whereas before we just had a value of m. So let's see if we can calculate what a and b are. So same idea as before. I'm going to write out all my vectors. So let 5 comma 8 be equal to a times -1 and 3 plus b 2 comma 4. So I've just plugged in my vector values, and now I start setting up equations, right? And now I've just got my first equation, so let's label it 1, which is, I'm also going to label it my I components here. Equation 2 will be my j components. I've got 5 is equal to -1a, so minus a, plus 2b. And then here I've got 8 is equal to 3a plus 4b. And now, whichever way you want to solve this is 100% up to you. Sorry, let's move this cable out of the way. Whichever way you want to solve is up to you. What I'm going to do is just multiply the top equation by 3 to solve it via elimination, but you could use substitution if you want to as well. So what I'm going to do is just do multiply by 3, so my new equations will be 15 is equal to minus 3a plus 6b, and then my second equation remains unchanged, of course. Now, adding my two equations together, these by design have canceled out. 15 plus 8 is 23, and 6 plus 4 is 10. So, unfortunately, it's not going to simplify to just give us a simple integer, but the numbers aren't too ugly. So b will just be 23 over 10. All right, and now I found b. I just need to plug back in to find a, and I'm just going to pick my most simple equation. I'm going to use this one before I multiplied it by 3, just because I've already got a with a coefficient of -1, so it's not going to be, the calculation won't be too hard for me. So sub into equation 1. So I've got 5 is equal to -a plus 2 times my b value of 23 over 10. And now just our calculation. The 2 and the 10 simplify, so I'm left with 23 over 5. I won't skip any steps, so minus a plus 23 over 5. Now let's just move the a over to the other side. I don't know why I'm thinking about this so much. So I'm going to move the a over to the other side so it becomes positive, and the minus 5 over here. So the 5 over to the right side, so it becomes 23 over 5 minus 5. Then, again, just our simple calculations. A is equal to 23 over 5 minus 25 over 5, right? Because we need our common denominator. And then after that, 23 minus 25 leaves us with -2, so I'm going to end up with -2 over 5. Again, you'll have to excuse my slow calculations. It is pretty late. So now we found our two values, but remember, we still have to make our statement. So making our answer nice and neat. So vector x can be written as -2 over 5 vector u plus 23 over 10 vector v. And then we're happy. Okay. All right. So one more video in the playlist, and then that'll be it for our lesson. So